Welcome, everyone. In this video, I'm going to look at solving equations that contain radical or expressions that have roots in them. And the thing is that it's not just a radical with a number in it, but the variable is actually inside the radical. So those are the examples that we're looking at here. I do have the basic steps written up top here. So if you want to pause the video, you may want to copy these down. The big thing is that we always try to isolate the radical to get started. So meaning you try to get the radical by itself. If you have more than one radical, and we'll see an example of that as well, then you would put one radical on each side. But your goal is to have just one radical on one side of an equation. Then what you're going to do is you're going to use whatever kind of radical it is. So here we have a square root. So you use a square then and raise both sides to that same power. That will allow us to hopefully cancel out the radicals. You would then simplify. If you still have radicals left over, we repeat that process again, and then you should have a regular equation just to solve. The big thing, though, to watch out for that is really important is that with radical equations, and there's other types too, so rational, where you can have x's in the denominator, and also radicals, where you can have x's under roots, often produce what are called extraneous solutions. So those are actually solutions that don't work. What happens is when we start squaring things and multiplying by x's, we can just produce extra answers by accident. So you always have to check your solutions at the very end, and you're going to do that by plugging it back into the original problem. So that is a really important thing here in this video. All right, so here's our first example. We're going to solve the square root of 2x minus 3 equals 9. So notice here that the first step is already done. So the radical is isolated on one side of the equation. It's by itself. Everything else gets moved to the other side. What I'm going to do next is I'm going to look at the type of radical it is. Here I have a square root. So I'm going to use a square then, and I'm going to square both sides of the equation. I do have to square both sides to keep it balanced. Now what happens is because the left side is just a square root and a square, that will cancel out. And then we're left with just 2x minus 3. And on the right side, 9 squared is 81. Now we have a regular equation to solve. We're going to add 3 to both sides. So I have 2x equals 84. And I'm going to go ahead and divide by 2. And when I do that, I get x equals 42. Now, again, the big thing you do have to do here is you do have to check your answers. And you're going to do it by going back to the very beginning of the problem. You're going to plug it in. And you're going to just simplify. So when you check here, it's really important that you don't start squaring both sides. That is not how you check. You check by plugging in and just simplifying what's there. So 2 times 42 would be 84. 84 minus 3 is 81. And the square root of 81 is, in fact, 9. So for your checks here, it is really, really important that you just plug in and you simplify. If you start squaring both sides, it doesn't correctly check the problem. So it's important that it's just a plug in and simplify when you check. This works. So x equals 42 is my solution. All right, let's look at another example. So I'm going to focus on the example up top here. Now notice that this one is not ready to start yet. I see a square root, but I also see a plus 3 hanging out on the same side as that square root. So I want to bring that 3x to the other side and get that root by itself. So I'm going to go ahead and subtract 3x from both sides. And I will have the square root of negative 10x minus 1 is equal to negative 3x. I don't need that plus 0 there, so I'm just going to use the negative 3x on the right side. Now my root is isolated, right? It's by itself on one side. It is a square root, so now I'm ready to square both sides. On the left, that square root and square will cancel, and you're left with just negative 10x minus 1. On the right side, you have negative 3 squared, which is positive 9, and x squared, which is x squared. Now, here I see I have a quadratic. So I'm going to see if I can factor this and solve that way. So I'm going to bring everything to one side first. So I'm going to go ahead and add the 10x and add the 1 to both sides. I'm just doing it at the same time. So then I have 0 equals 9x squared plus 10x plus 1. Now, not everything is factorable. So we're going to have to check this here and see if we can factor this. It actually does factor. It factors as 9x plus 1 and x plus 1. That would multiply out to give me this expression here. And then don't forget, we set each of these factors equal to 0 and solve. So in the first case, I subtract 1 to both sides, and I get x equals -1. In the second case here, I also subtract 1 to both sides, and then I divide by 9, and I have a second answer of x equals -1/9. So my two answers here are x equals -1/9 and x equals -1. Now, don't forget, it is really important that you go ahead and check these. So what you're going to do to check is you're going to just take your time and plug each of them into the equation. So let's go ahead and check -1 first. I go back to the original. So -10 times -1 minus 9 plus 3 times -1, is that equal to 0? Well, -10 times -1 is 10. 10 minus 9 is going to be 1. So I have the square root of 1 minus 3 here. Is that equal to 0? Let's see here. Oh, I have a mistake. I apologize. Let's fix that. There should be a 1 there. I was doing the math in my head and I wrote down the wrong number. So let's try that again. It's -10x minus 1 here. So -10x times -1 is +10, and 10 minus 1 is 9. 3 times -1 is -3. And then we do get 3 minus 3, which actually is 0. So this one does work out. I always like to say, too, if you find that your check doesn't work, check it first before you erase the whole problem and start over again. A lot of times, myself included, we make silly mistakes in the check. So if it's not working out and you feel like maybe it should have, go back and double check your work here. So what I was doing is I was doing the math in my head, and instead of writing down the original problem, I was writing down the answer and I was getting it wrong because I wasn't organizing it correctly. So slow down for a second, make sure you did your check correctly. And then if it's still not working, then you know you probably have either an error or, in this case, an extraneous solution. I'm also going to go ahead and check that x equals -1/9. I'm going to go on the back side here because this is going to take a little bit more time. So here, those two negatives will cancel. I have 10/9 under my root here. Now I have a -1. I'm going to do a couple steps at once here. I'm going to do common denominators. So 1 is the same thing as 9/9. So I'm going to change this to -9/9. This becomes -3/9. Oops. 10 minus 9 is 1. So this becomes the square root of 1/9. And this becomes -3/9. Now the square root of 1/9, remember, I can break this down to the square root of 1 over the square root of 9. So that becomes 1/3. This I can also divide by 3/3, and I have 1/3. So I do get that this one also checks out. So for this particular example, both of these solutions are correct. So I have two answers here. Another way you can write the two answers is you could write it as a solution set. So I could write it as -1/9, comma -1. But notice I'm using squiggly brackets around that, not parentheses or something like that. So that is set notation, which just means that these both are solutions here. All right, and let's do one more very similar style here. So this one I have a cubed root, but it's going to be the same process. I'm going to start by bringing the 5 to the other side. Okay, so as I was saying, when we subtract 5 from both sides, we're going to have the following. So it'll cancel on the left. We're left with the cubed root of x plus 1, and then we have -2 on the right. Now, again, notice that our cubed root, here, is already isolated, meaning it's by itself on one side of the equation. So because it's a cubed root, I'm going to cube this time. That will cancel this piece out. I'm left with x plus 1, and negative 2 cubed would be negative 8. Okay. Now I'm going to subtract 1 from both sides, and my answer is x equals negative 9. Now we do have to still check this. I go back to the original. I plug in negative 9. Negative 9 plus 1 is negative 8. Cube root of negative 8 is negative 2, and this happens to also check out. Negative 2 plus 3 is equal to, negative 2 plus 5, excuse me, is equal to 3. So we're all set there. So our answer here is x is negative 9. And again, if you prefer to write it in set notation, we would use those squiggly bars with the negative 9 inside, which shows it's a set and not a point or an interval or something like that. All right, now this one is set up and ready to go. So notice that my radical is on the left side, everything else is on the right. So the radical is already isolated. This is a square root, so we're going to square both sides. That will cancel out the root piece. I'm left with 4 minus x. On the right here, sorry, we're squaring this as well. So you may want to write this out unless you can do the squaring in your head. And we're going to distribute. So x times x is x squared. Next, I have a negative 2x. On the inside, another negative 2x, and then a positive 4. I can combine my like terms here. And then I am going to bring everything to one side. So I'm going to subtract the 4 and add the x. And I have 0 equals x squared minus 3x left on the other side here. Okay. Now I'm going to try to solve this by factoring. This is actually a pretty quick one to factor because I can just take out that GCF of x. And if I do that here, I'm left with an x and a minus 3. And then I set each piece equal to 0. This is already solved. This I can add 3 to both sides. And I have my 2 solutions. Now again, we get to check them. So let me start by checking x equals 0. I go up to the original here. I get the square root of 4 is equal to negative 2. Now this does not work because the square root of 4 is positive 2. So actually x equals 0 is not a valid solution. So this is our first example of an extraneous solution that is not working here. And I am going to check the other one though, because it doesn't necessarily mean that the other one has to work. 4 minus 3 is 1, 3 minus 2 is 1, and you can see this one does work. So the square root of 1 is 1. And we do have one solution here. There are cases where they may both not work, in which case you would have no solution. So you really have to check them all individually. Some examples you may have multiple solutions, others you may have no solution or just one solution. So it is important to always check your answers there and watch out for those extraneous results. Now, the last example I want to show you is a little bit more complicated where you have 2 radicals. So if you have more than one radical, the first thing you need to do is make sure they're on separate sides of the equation. So I'm going to start by bringing this over here. And if it's addition, I'm going to go ahead and subtract it from both sides. All right. Now I have square roots, so I am going to square both sides. And this is where you have to be careful. On the left side, the square root and the square cancel, right? Because there's nothing else there. It's just a square root being squared. So those are going to cancel. On the right side, though, I can't cancel this root by itself because I'm not just squaring the root, I'm squaring the whole thing here. So when you're squaring something that has subtraction or addition with it, you're going to have to FOIL or multiply it out. So this is going to be 3 minus the square root of 2x times 3 minus the square root of 2x. So it gets much more complicated when you bring in a radical with addition or subtraction on one side. All right, so 3 times 3 is 9. Here I have minus 3 root 2x. On the inside, I have another minus 3 root 2x. And then I have a negative and negative is positive. So root 2x times root 2x. These I can put together. They are like radicals. So -3 and -3 would give us a -6. Here, notice I have the same thing twice, right? I'm taking that 2x and I'm multiplying it by itself. So that 2x is being squared. So this piece does cancel for the radical. And I'm going to start cleaning it up now. So one thing I'm going to do is bring the 2x to the other side, and you'll actually notice that they happen to cancel on both sides. That doesn't always happen that way. It just happens that way here. I'm going to subtract the 5 from both sides with the 9. So let's see, I have 0 equals 4 minus 6, all root 2x at this point. Okay. So I've cleaned it up as much as I can. I still have a radical left over. So what I'm going to do now is I'm going to repeat this process again. So I'm going to get radical on one side, everything else on the other. So for me, I'm going to add the 6 root 2x to both sides. I just like to keep things positive when I can. So I have 6 root 2x is equal to 4. I'm also going to get rid of the 6 out front here. There's different ways you can do this problem, but I like to just get rid of that 6. I find it easier. So I have root 2x. Now 4 over 6 can be simplified to 2/3, right? I can divide those both by 2. So I have 2/3. So I like to simplify as much as I can and really get that radical by itself. Now I'm going to go ahead and square both sides again. Now, because it's only the radical over here, there's nothing else. It's just the radical. It is going to cancel. So I have 2x. And over here, 2 squared is 4, and 3 squared is 9. And my last step is I'm going to divide both sides by 2. It's a little bit weird, but when you divide by 2, it's the same thing as multiplying 1/2. So the big thing is that that 2 is in the denominator over here. It's not up top or anything. So what happens is x is going to be equal to 4 over 18. And I can divide these both by 2 as well, and I get 2/9. Now, we're not quite done. We are almost there, but you do have to go ahead and double check your work. So that is going to be our final piece here. I'm going to try to do the check on the left. And I go back to the original. So I'm going to go ahead and do 2 times 2/9 plus 5, all under the radical, plus root 2 times 2/9. And I'm going to see if that's going to equal 3 on the other side. I'm going to just not write it in because I'm running out of space here. And I'm going to keep simplifying. So I end up with the square root of 4/9. Now I want to do common denominators. So 5 is the same thing as 45 over 9. So I'm going to go ahead and change this to 45 over 9. Here I also have 4/9. And again, don't forget there is an equal 3 on the other side there. 4 plus 45 is going to be 49. So I have, 49. So I have 49 over 9 plus root 4 over 9. Is that equal to 3? Well, 49 and 9 are both perfect squares. So the square root of 49 is 7, and the square root of 9 is 3. Here, the square root of 4. Let's see, is 2. And the square root of 9 is also 3. Now I already have common denominators, and 7 plus 2 is 9. And this actually, it's a lot of work, but it does actually check out. 9 over 3 is 9. So again, don't skip that last check. You can use a calculator to help you as well, although with fractions and radicals, it is a little bit more challenging because if you round or anything like that, you could get some weird results. So you may want to just do a little bit of work with those fractions and take that extra minute or two to make sure it checks. But this one does check, so we have our final result here. So these, when you have multiple radicals, can often be more complicated. You do want to make sure you have one radical on each side. Here I have a square root, so I'm going to square everything. And what happens sometimes is that the other radical may not cancel right away, and it won't cancel if you have additional adding or subtracting. If I just had a radical and a radical, then that would be pretty quick because they would both cancel. But if you have additional subtraction or addition, with your radical on the outside like this, when you square it, it's a little bit more work. You're going to have to multiply that all out, and you may have to square it more than once. So those are the ones to watch out for and keep practicing with.